So thanks for being with us tonight. Thanks for being with us this morning. So we'd like to discuss about upstream bug triage and what you can actually get by doing that job. So first of all, let us introduce ourselves. Sorry. Oops. So I'm Sylvain Boza. You can see here my Twitter account and my RC name if you have any questions after that specific talk and you want to discuss with me. We both work at Red Hat, and let me introduce you, Stephen.
Yeah, so I'm Stephen Finucane. I also work at Red Hat. We're both Nova cores, and I don't look like that anymore. I just don't have a better photo. So we're obviously not doctors, and yet we're here talking about triage. So a little bit of information about what bug triage actually is probably going to be helpful. So the important thing to realize about this is that bugs will always exist. There's a couple of reasons for this. Key among them is the fact that there's obviously technical debt. When you're talking about something the size of Nova that's been going on for so long, the features that are in Nova and what people actually care about in those features and who's working on them, everything's changing the whole time.
So in order to tackle those bugs, given that we're all humans, we cannot reasonably assess that we can target all of those. So for that, we are getting help from of course, unit and functional tests. And also remember that we had a presentation of Zulfi 3 this morning at the keynote. We have a gating CI that helps us tackling all the possible problems that we have when we want to merge some specific patch in the code. Our OpenStack infrastructure is also shareable with partners. For example, some vendors that have some specific features and want to test those specific features. So we have some reports coming from third-party CIs, like the ones that you can see on the screenshot. And of course, remember that we have a Git review system that helps us discussing with, for example, the people that could probably identify some possible code. And one also important point to emphasize is that we're working on an open source project, but we also have part of our job, which is about having to work for a specific company, working for some people on a specific product, and for that we have also some downstream validation coming from the downstream vendors that help also to tackle some bugs that are related to their own distribution. So when you think about bugs, obviously you identify that bugs are identified by operators, of course, because that's the people who actually play with the code that developers are writing. That's totally worth it. But also one important thing to keep in mind is that some important portion of the bugs that are open within the projects also come from the developers, because that's actually the people who also test the code when they actually write it. And so we have both bugs coming from operators and developers. And in general, the boundaries are not that set, because also, for example, you can imagine some developers that are also part of a company who operates a cloud. So also they can provide also some bug reports, because, for example, they discuss that downstream for their specific product.
Different people report bugs. Different kinds of people also actually work on those bugs. Usually the ones that most people would probably be familiar with are like what we call the white knights. So these are the guys that are upstream first, the guys that you'll see hanging around in IRC channels pretty much 24/7. But if you're talking about bug triage, it's also been important to be aware of the other two types of bug fixers. So the main experts are the guys that you'll go to if you have a problem with a specific area. So from the context of Nova, if it's to do with like the PCI subsystem and that, this comes with time, but you build up kind of a mental model of who's the best guy to go and talk to about this. And there's also the on and off contributors. So these are guys that would submit a fix and then might disappear, and you see them again 6 months later. We're going to go into this in a little more detail in a bit, but from the perspective of triage and code reviews, it's important to pay attention to contributions from these guys. They might be spotting things that you would not see in everyday deployments because they're doing something fairly like esoteric. And if they submit a fix, it could be a perfectly valid fix, but they might just submit it and disappear. That might necessitate someone stepping in at some point in the future to resolve that. Another thing also worth pointing out, we are an open source project. More information on this in a bit, but just because a bug exists doesn't necessarily mean there's no contract there that that bug is going to be fixed in the next week, in the next month, in the next year. It's very much tied to what the project considers important, what the people working on that project consider important.
So let's stick with the medical reference because we are not doctors. So here is just an example of a Launchpad bug. For those who see that as the first time, there are a couple of information that are worth to notice, like for example the bug status, the bug importance, and the bug tags. For the records, we use Launchpad for triaging our bugs. That's something that we had since the very beginning of OpenStack. So you could probably use, for example, some other bug tooling for your own corporate bugs, I would say. But that's why, for example, in OpenStack, we have some taxonomy of a bug that is very Launchpad specific. That's mostly because of our reporting tool. So for bug statuses, I don't want to talk about all those statuses, but I just want to highlight a few of those. So of course, there is the confirm bug. There is a confirm status, sorry, which is when someone is actually triaging the bug and making sure that there is actually a problem. So he's putting the confirm status. There is some status which could be a bit confusing for people first looking at all the code, because in progress doesn't really mean that the bug is actually being working on. It's more about the fact that someone in the past provided a Git change, and given that we have a Git hook that modifies the status of the bug, it changed that to in progress. So that could also be a problem for triaging, because if you only look at the new bugs, you could probably miss the other in-progress bugs. But for the good or the worst, that's also a key indication that a solution has been already provided. And last one, it's about fixed release and fixed committed. It can be a bit confusing if you're looking at that, because sometimes you can see a bug which is fixed committed and the other times which is fixed release. I just want to explain that when a bug is fixed against the master branch, this is in general fixed release because that's the master branch. And when you actually backport a bug to a stable branch, then it's fixed committed until someone is providing a stable version. I mean, is doing a point release upstream.
We've also got the second thing, bug importance. Once again, I'm not going to go through the full list of this. The two important ones are critical and the wish list. From the perspective of critical, this is one of these bugs. They usually pop up around release time. This means that it's something that's going to, like we say here, break the world. So it means that there's possibility of data loss, or my cloud no longer works. And usually this means that you're affecting something simple like, for example, basic Nova boot with standard flavors and standard images. The wish list then is the complete other side of this. Wish list bugs don't necessarily have to be bugs. They could be something as simple as what we call in Red Hat anyway, a request for enhancement. There's something that we're not going to be closing as invalid, and someone might work on them in the future, but it's not a priority for the project. We're going to go into a little more information on bug tags in a short bit. That's the third one of those items that we showed up before.
Project-specific, so we prefer to discuss that for the specific project we are talking about. So now that we discussed about the bug by itself, it's pretty good to know how to triage those bugs. So here we wanted to provide a bit of rules in order for you to not get insane. So of course, those are just advices, and you are totally reasonable to not follow those advices. But here are a couple of things that you could know. So first of all, when you look at all the bugs that are open against a specific project, you also need to keep in mind that a specific portion, over time it depends. It could be more than 50%. Some bugs are not really bugs. Either it's because it's a configuration issue. I mean, you wanted to test something and it failed, but that's for example because you didn't provide the good DB credentials, and then you get an exception. But then, in that specific case, it's not considered as a bug, and your bug will be considered as invalid. Of course, that doesn't mean that you won't get your problem solved, because you can just jump on the Nova channel or any project-specific channel and ask for a resolution. Or in general, if it's a configuration issue, you have a specific OpenStack channel that helps you finding a solution. But Launchpad is not the good place for discussing about your problem. Also, sometimes if you just say, okay, my VM is not booted, my VM is not booting, I have a problem, it's of course missing information, then we are putting the bug as incomplete and asking you for more information. And also the last important thing, which can be a bit difficult to understand for the first time that you're opening a bug, it's because we don't use Launchpad like other open source projects use, and in general that's even not in general, we don't use Launchpad for all the feature tracking. That means that, for example, say you would like to use a specific feature and you identify a gap in that specific feature, then if you are writing a bug saying, for example, hey, look, for PCI, I just would like to do some fancy stuff with PCI, but I'm not able to do so, then we'll close that bug as invalid because that's not the right place to discuss about that. And we have a separate tracking system for the features, but that's not the purpose of that talk.
So tied into this, if you're doing bug triage, it's important to get as much data as possible from the perspective of whether doing something like reproducing this bug, writing a test to prevent the bug, and obviously fixing the bug. So there's a few things that you want from this. Stack traces, super helpful. If a service has failed, you'll usually get some information about where exactly that failure lies. You also want to figure out what release this is targeted against, because we have different policies across OpenStack for what types of bugs we'll fix, ranging from any form of bug to critical bugs to no bugs in the case of EOL releases. And then obviously we want to do some basic kind of categorization, so make sure that the bug doesn't already exist and make sure that the bug isn't a critical bug that everybody needs to jump on and resolve ASAP. And then tied into this again, reproducibility. A bug it might still be a bug, but we can't do anything about it if we can't actually reproduce that bug. So functional tests, something like keeping the reproduced test case as small as possible, being aware of things like hardware dependencies. So is this a bug in SRIOV? Therefore, what types of SRIOV device do you need? Are you able to reproduce this in the gate if it's not hardware dependent, that kind of thing. This all helps with us actually writing bug fixes and then making sure that these things don't regress in the future.
So as we said previously, we are also an open source project, and we don't pretend to tackle all the bugs because we don't have the resources for that. And given that bug triage is made on a volunteer basis, we can't really have the bandwidth to target all of those. So that's the main reason why we actually care of the new bugs that are coming in, and we just try to make sure that all of this get a proper, I would say, header tag or communication system that help us to know that okay, there are bugs and we keep track of those, and it's then part of any subdomain experts to look at those bugs and to try to fix those. But as we said, there is no clear engagement, I would say, to the resolution of that bug, rather about making sure that we have enough information so that someone can pick the bug. So, for example, if you triage the bug, of course, you can actually fix it, which is like the better, but you're not out to, you are not engaged to. So yes. And as we said, the more information we gather from the bug report help us to identify the specific component that it's impacted, and for that we use tags, which are very project specific and definitely help finding other people that can look at the bug.
So we touched on this previously, but there's usually from a customer or user perspective, there can be a bit of a disconnect between the priority that we use in Launchpad and the impact that it might have on you as an OpenStack user. So if you're doing triage, you're going to spot this yourself, and you might see a little bit of conflict over this. It's kind of inevitable. But the way that you want to try and figure this out is you want to think about broader OpenStack customers. So a critical bug that breaks, we'll say, SRIOV functionality for a user, we wouldn't necessarily mark that as critical because we don't consider SRIOV to be something that 100% or even 90% of Nova users are actually using. Something, on the other hand, that breaks the ability to boot a basic image with a basic flavor or stops the API from working, that is a critical bug. And if you're doing triage, it's entirely up to you to make that decision. You might have someone arguing with you, but in general, try and keep the focus on the broader OpenStack use base.
So given that we have a huge number of open bugs, and you will get some metrics from Nova just after that, it's pretty important to follow the advice that you shouldn't really care more than 10 minutes for a specific bug, because if by trying to identify about the root cause it needs you more than 10 minutes, that's probably either it needs more information, or you're probably not the right person to look at the bug, and you should probably ask for help from some domain expert that it's tied to. For example, say, I would like to investigate about a specific SRIOV issue, but I'm definitely not a domain expert of SRIOV. It could be very hard to identify the root cause, and for that, of course, it would require me more than 10 minutes. But then I will like leverage the project community and ping other people that I know that are pretty domain experts of SRIOV, so they could help me triage that bug and even think about a solution path for that one. I think we already discussed about that. Ask for help is pretty crucial, because that's not because you're looking at the bug that you're due to fix it, and again trying to identify other people that can help you to fix that also increase the chance of the bug to be fixed, because that gets actually momentum of on that specific bug report. And last point, but I think we already discussed about that. When you are doing bug triage on the Upstream project, you are not committed to fix that specific bug, but it's also pretty important to keep in mind that you have the ability to fix the bug if you want to. So that's pretty nice if you seriously think about that, because if you get help from other people that give you like a solution path about fixing that, you have all the keys for going within the community and provide your own patch.
So as promised, we're going to take a little bit of a case study in how a project does this, and obviously we've gone for Nova because it's the project that we both know best. So don't focus too much on this. I realize it's really small. There's a couple of things I want to point out in it. This is data pulled in from Launchpad directly and is mapped in using Grafana over the course of, I think it's about a month.
Last year.
Entire last year, okay. So there's different colors represent different categorizations of bugs. Firstly, to get a few kind of small things out of the way, big drops in bugs, there was a result of automated tooling that we have around bugs. So looking and seeing a bug might be marked as in progress, and yet there's no fixes associated with that. Chances are the person isn't working on this anymore, therefore we need to reset it back and let someone else pick it up. Or there's a bug fix up there and the bug fix no longer applies, or it was abandoned, something like that. Other things worth noting, there's a red line at the bottom which tracks the number of triaged bugs. Triaged was a state that we mentioned earlier that we don't really use. This is probably project specific, but we tend to put a bug into one of the other categories, so we mark it as incomplete or confirmed because we've actually fixed the bug, that kind of thing. But the actual reason that we have this here is there's an orange line there which tracks the number of new bugs. And we can see here that this was climbing rapidly up until a point in August. And at that point, it plummeted. And the reason that it plummeted was somebody sat down and did a load of bug triage over the course of a couple of days and filtered all of these bugs into different buckets. Now, that doesn't mean that we fixed all those bugs, because as we've discussed here, triage isn't bug fixing, completely separate things. But it does mean that there was more information provided to these bugs that meant that people can actually go and fix these a little easier going forward. And at the moment, this is slowly starting to climb back up again, which means it's probably about time that somebody sits down and does a triage exercise again to close this out. Looking back at the Pike cycle, two stats pulled in from Stackalytics. Firstly, the number of filed bugs, 827 versus the number of resolved bugs, 480. That doesn't mean that these are the bugs that were introduced in Pike or that were fixed in Pike. This just means that over the course of the 6 months or whatever that Pike ran for, this is the things that we fixed. Now, that can mean master branch, that can mean the other stable branches, or it can mean things that were marked as invalid and closed.
So since we promised you to show a bit of the Nova architecture, let's just give you a big diagram, because I know that some people love big diagrams. So here you can see a bit of Nova services, like the Nova API, Nova Scheduler, Nova Conductor, Nova Compute, and placement, and a bit of cell databases. Given this is not a technical talk, you probably wonder why we are just providing you a big diagram, and you're totally right. I mean, what you actually need to keep in mind when it's tied to bug triage is that most of actually the Nova services are actually tied to a specific notion in bug triage, which are tags. Here are, for example, all the tags that we have in Launchpad. And for example, you can see a tag specified for the scheduler, for placement, or for the Nova Compute. And that definitely helps to find some domain experts on their own expertise, having a specific expertise that can actually look at the bug and try to fix it. But that's totally understandable to have a specific tag for a specific component, but in general, this is not enough, in particular for the Nova Compute service, given that's a huge one, having specific virt drivers and specific features in it. So you can also tag a specific bug by having a specific driver. I would say that is virt driver related. Or you can actually also target a specific feature, like for example, PCI, or if it's, for example, neutron related, then you can actually use the neutron tag. So as you can see, that specific taxonomy, which is actually changing every day, doesn't really mean that you actually get a solution, but you will actually understand more the scope of that specific bug. And worth noticing it, we also have other tags that are not used to categorize what the impact is on the specific component or on the specific feature, but are also related to what impacts, for example, on our CI. So, for example, say you actually merged something that actually breaks Zool, then we try to identify that, because in general, that are the bugs which are the most critical, because we cannot merge any other code because of that. And last but not the least, there is a specific tag which is very common in OpenStack for all the projects, which is the low-hanging fruit. As a bug triager, I definitely love this one, because if I'm able to identify a bug where the solution path is quite easy to identify, and where the fix that I feel is like 2 lines of code to be changed, then I definitely use that specific tag. Because I know lots of people are looking actively at that specific tag for all the open bugs and are just jumping on that. I know this is not super great, because if you really want to integrate with the community for that specific project, using that specific, that doesn't really help you to get more knowledge. So that's also the purpose of that talk, is to explain you that doing bug triage will help you like more knowledge than just looking at the easy solvable bugs. But it's also good for resolution.
Release cadence as well ties into it's important to be aware of the release cadence of a project if you're doing bug triage. We talked before about critical bugs. We usually spot critical bugs when we come around to release cadence time, the release candidate time, because suddenly this work that we've been doing for the last 4 or 5 months, people actually start using that work, and you discover all these little oversights and mistakes and that you've made in the code. So when it comes to the release candidates, the amount of critical bugs in that usually jumps up a little bit. Keep an eye on the bug tracker, then focus your triage around that particular time if you can. And when it comes to actually merging the bugs, we do this anyway, but keep an eye on those bugs, see if there's something that they have to be backported to the latest stable branch for release, but they might also apply to other stable branches.
So I'll ask a few words to finish about that. Doing that job is, of course, something which is not very fancy, as we explain in the abstract, but you can actually see huge benefits in that. The main important benefit is that you can very easily gain some technical expertise on the project that you are actually triaging bugs. Because, and I think I discussed that a couple of minutes ago, it requires you to identify the root cause, to go deep into the code, and to try to identify what's wrong. And for that, you are not alone, because you can actually ping other people for a specific bug, which means that there is something that people care about. And just trying to think about that, just trying to step up a little bit, if you consider that, rather than just focusing on the low-hanging fruits, which is like the easy thing to do, if you take a bit more of time and look at the bugs and just try to identify the specific resolution path, it will give you a visibility to the project's community that you help, and will actually gives you ways to know other people in order to help you fixing that specific bug. At the end of the day, you will be sure that you will know other people working with that specific project, because you will, for example, you will begin to know which specific domain experts for that specific feature are, or you will also know, for example, the Y Knights and the other guys. And that gives you like a way to engage with the community in a much better way, from my personal opinion, than just looking at either the low-hanging fruits or just providing your own feature, because you get a broader knowledge of the code base of the project. And at the end of the day, like I said, other people will know you as well, which also make you you will be okay with that, because given other people will actually know you, other people who could actually trust you, which is like the key thing in an open source community. And last point, there is a specific title in OpenStack for those people who like actually title, which is BugSAR, which is for every OpenStack project, which just means that you are actually volunteer to dedicate on bug triaging. I'm not saying that anyone can just. I mean, you're not out to become a bugster if you look at bugs. But I mean, that's just increase your visibility as one guy just looking at bugs. And it's also good if you're willing to take that specific position, because we'll totally trust you about all the things that you are having in mind about how to help with triaging the large number of bugs and the other things. I know, for example, for the Nova project, we had a very good person who was actually acting as the bugster, but actually resigned from his position because he switched his corporate focus from OpenStack. So the position is open, but you actually have, for Nova, we have a good idea, we have a good example of some good work made in the past. Last point, I would say the first step for doing bug triage is at least to join a specific Launchpad group. This is very Launchpad specific, but you can't actually do bug triage if you're not part of that group. This is the way it is. So this is the information for Nova, but I guess for Neutron and for Cinder, this is pretty the same. I guess they have a specific Launchpad group for that. So just click on the link for Nova, or buzz other people for other projects, for example, in their own IRC channel, and ask if you're willing to do bug triage for that, which specific group you have to join. And then, like we said, I think a couple of times, anyone can do that. I mean, I think for Nova, I didn't check the stats, but I think we have more than 100 people that are actually part of that group.
It's about 800. It's about 800.
800 even. Right. Okay, so that's actually pretty huge. So you can actually just triage any bug like your colleagues, or you can do more than that, but that gives you an idea of the fact that anyone can just triage, provided they were part of that group. A couple of resources, of course, you cannot click on that now, for sure, but you will get the slides. So I hope that you will get the resources if you would like to. So there are a couple of wiki pages that are actually pretty old and need some kind of refresh. But I think for Nova, most of the tags are there, and most of the tags, for example, are also having an owner that is identify, I guess, those specific tags. So for example, if you click on the first link, then you will get the list of all the tags that we use within Nova and a list of IRC nicks to bother if you wanna, kind of having the resolution path for that specific tag. The old OpenStack wiki rules, the old OpenStack bug triage rules are there. I don't think they merged that in the new documentation system, but anyway. And I'm providing the link to the Grafana URL that we used for generating, the velocity slide. That's made from someone who was the former bugster in Nova and who developed that specific tool for that. So thanks to him. And I think we are done. So if you folks have any questions,
ask him. Yeah.
Or him.
Anyone here do bug triage already? Okay, right. Anything to share? Anything to add to that? Other than please do it.
I've sent some things to the mailing list in the past, but it turns out that a lot of the time, several bugs, if you do triage daily, several of them are just like, the Nova API says, I should report a bug, and I haven't configured how to use glance. So most of the bugs are just automatically invalid, or their support requests. Eventually, if you're doing it daily, you see the trends and you get to see, it just becomes obvious what is going to be invalidated. Or I hit this thing and there's no reproduction information, it doesn't tell you about release.
So just to repeat that back for the recording.
Yeah, sure.
What Matt's saying is a lot of the bugs are usually pretty naughty things. You can just close them straight out because it's like we said earlier, it's a misconfiguration issue. or it's an issue where there isn't enough information provided and therefore we can't reproduce it.
Any way of enforcing in Launchpad that people can't actually make those kind of bad bug reports and make it impossible to report a bug if you don't specify the release, for example?
So we actually have a template for that, for every project, that in theory, you have to follow the template for filling in the bug that requires you to provide more information than just, okay, I have a problem. But the problem with that is that, in general, in the past, what I saw, for example, is say you have a distribution, and like Matt said, you have a specific stack trace that's bubbling up. Then people are filling a bug against it, but it's missing crucial information, like, for example, whether it's a distribution-related stuff, or even which release it's impacting, that kind of stuff. So that's also why most of the bugs that are currently open require some kind of specific treatment for that. I know that Sean Dag, for example, tried to categorize automatically the release, given, for example, the stack trace and a couple of information with that. But that's not like things we can really automate and we can't really prevent. We can surely do things like, for example, stack tracing, that you have to provide a bug report every time that you have a bug with the Nova API. That's probably something that we can discuss within the Nova community, whether it's still good or not. But for other things, that still requires some human action.
Reminds me a little bit about the patch submission, where someone does like typo fixes and that. It's very much, bad bugs are very much a social issue as opposed to something that we can automate away. It's a matter of education and talks like this, in my opinion.
I think we have 1 minute left, so if you have any question, then just one. Cool.
Thank you.
Yep, it will be on the OpenStack videos page. We still have to provide the slides, but
we'll put it on the mailing list.
Yeah.
Cool.
Cool. Thank you.
Thank you.